Hey everyone, today we're going to solve a trig equation. And so on top, we'll notice that we have a sine squared x and everything else in terms of cos x, right? Cos x or cos squared x. And so first thing we should do is find a way to relate sine x to cos x, right? If you've done enough of these, you'll notice that 1 minus sine squared x is our very first identity, right? That's equivalent to cos squared x. And so we can make a substitution using that identity. I'll even make a note of that, identity. Right? That's not how we spell identity. That's how we spell identity. And that identity, for the record, is sine squared x plus cos squared x is equal to 1, right? We just moved it around and isolated cos squared x. And so now our equation reads cos squared x minus 2 cos x all over that very same denominator, cos squared minus cos x minus 2. And all of that is equal to negative 1, right? Now you might notice that these are quadratics in both the numerator and denominator, so we can factor them, right? The numerator factors as, we can factor cos x from both terms, and we get cos x minus 2 all over, this factors as cos x minus 1 times plus 1 times cos x minus 2. Yes, yep, that's the one, is equal to negative 1. And so now we can go ahead and solve those. So we'll notice that the factor of cos x minus 2 is common to both the numerator and denominator, meaning we can cancel it out. But we can cancel it out if we're mindful that this could give us some non-permissible values, right? This could cause a problem. If this factor was 0 in the denominator, it would make the entire denominator 0, right? 0 times anything 0. And that would make us have a division by 0. We can't risk that. And so this reminds us to state our non-permissible values. And so we'll make a section for our NPVs. Those would come from, again, that cos x minus 2 factor being 0, right? And so we just can't have that. So our non-permissible values are all values of x where cos of x is equal to 2. But conveniently, there are no solutions to that equation. And so cos of x is never equal to 2. And so there are no non-permissible values. Okay? Cos of x is never bigger than 1, right? And so then we can go ahead confidently with what's left. And so we have cos x over cos x plus 1 being equal to negative 1, right? Let's multiply both sides by this cos x plus 1 factor. And so cos x plus 1 on both sides, like so. And so now we have cos x is equal to negative cos x minus 1, right? Did I do that right? Cos x, negative 1 times cos x, negative 1 times 1, beautiful. And so that means that we are going to isolate the cos x terms. I'll even do that out explicitly, plus cos x on both sides, right? So now our left-hand side is 2 cos x, and that's equal to negative 1. And now you can see we're almost done, dividing both sides by 2. I'll color code this to the best of my ability. Whoops. Let's not do that. And so we are solving the equation cos of x is equal to negative 1/2, meaning that we grab solutions. X is the inverse cos of negative 1/2. And so x is equal to, we didn't say for what interval we wanted to solve this for. Let's look at all possible solutions in radians, let's say. So negative 1/2 for cos, that is at 4 pi over 3 and 5 pi over 3. And so we'll do 4 pi over 3 plus 2 pi k. And in Q4, that's not it. That's not it. We want, I'm so sorry, 2 pi over 3 and 4 pi over 3. I mistook cos for sine here. 2 pi over 3, that's in Q2, right? Cos is negative in Q2 and Q3, so 2 pi over 3 plus 2 pi k, as well as 4 pi over 3 plus 2 pi k in both cases for any integer value of k, right? This bubbly z symbol is the set of all integers, and so k being any element of that set means k can be any integer value. And so this is our solution set. We should write this as a set of solutions, since there are infinitely many inside said set. And that is our solutions. So we did state any possible MPVs. We found none. We found our solution set, and so we're done. I hope this helps, and thanks for watching.